day. My name is Robert Seth Magallanes.
And my name is Mandamiento. Today, we will present to you the theorems 7 to 18.
We hope you learned something from our video.
Theorem number 7. Two lines perpendicular to the same plane are parallel. And conversely, if one of two parallel lines is perpendicular to a plane, the other is also. So we assume that these two edges are our lines, which is perpendicular to the same plane, which is the floor. So they are said to be parallel because in theorem number 7, it is stated that two lines are perpendicular to the same plane are parallel. So these two edges are parallel to each other.
Theorem 8. If a straight line is parallel to a given plane, it is parallel to the intersection of any plane through it with the given plane.
Let's say we have two planes. This is plane 1, which is the wall, and plane 2, which is the floor. Now, plane 1 contains a line that is parallel to the floor, to plane 2. Now, in theorem 8, it says that if this line is parallel to the floor, and the plane then the plane that contains this line is parallel to the intersection of these two planes, which is this line right here.
Theorem number 9. If each of two planes is perpendicular to the same line, they are parallel. And conversely, if one of two parallel planes is perpendicular to a line, the other is also. So, if we have two planes here, which is this plane and this plane, and they are said to be perpendicular to the same line, which is this line, they are said to be parallel, according to the theorem number 9.
Theorem 10. If a plane is parallel to each of two intersecting lines, it is parallel to the plane of these lines.
Assuming that this plane is parallel to these two intersecting lines right here, then theorem 10 states that this plane is parallel to the plane of these two intersecting lines, because according to theorem 2, two intersecting lines make a plane.
Theorem 11. Through a point not on a plane, there is only one and only one plane parallel to this plane. So we have here a point, not on this plane, the other plane. So there's only one and only one plane parallel to this plane.
Theorem 12. Through one of two skew lines, there is one and only one plane parallel to the other line.
So theorem 12 basically says that we have two skew lines, let's say this line over here and this line over here, two skew lines. Now it says that there's only one plane which contains the other line. Let's say this plane which contains this line can only be parallel to this line.
Theorem number 13. Through a point outside of each of two non-parallel lines, there is only one and only one plane parallel to both of these lines. So theorem number 13 says that through a point not on two non-parallel lines, there is only one and only one plane parallel to those skew lines. So assuming that we have our two non-parallel lines here, which is this line and the other one is here, and our point here is right there. So we can draw a plane here which is parallel to those line, which is right there and right here.
If two intersecting lines in one plane are parallel, respectively, to two intersecting lines in another plane, then the two planes are parallel, and the corresponding angles formed by these lines are equal.
So theorem 14 basically says that if two intersecting lines in one plane are parallel to two intersecting lines in another plane, that means the two planes are parallel, and the corresponding angles formed by these two lines in this plane and these two lines in the other plane, the corresponding angles are congruent.
Theorem number 15. If two straight lines are cut by three parallel lines, the intercepted segments on one line are proportional to the corresponding segments on the other. Theorem number 15 simply says that if we have two lines here, straight line, this one, right, this one, cut by three parallel planes, which is these three planes, their intercepted segments are equal, which is this line are equal, and this also are equal.
Theorem 16. Two dihedral angles are equal if their plane angles are equal. And conversely, if two dihedral angles are equal, their plane angles are equal.
For theorem 16, we must first identify two dihedral angles. The first dihedral angle is this one, and the second one is this one right here. Now, these two dihedral angles are equal if their plane angles, this plane angle for this dihedral angle and this plane angle are equal.
Theorem number 17. If two planes are mutually perpendicular and if a line is drawn from a point in one perpendicular to their intersection, then this line is perpendicular to the second plane. For theorem number 17, we have a plane here which is mutually perpendicular to this plane, and if we draw a line here perpendicular also the intersection of these two planes, then this line we drawn here is perpendicular to the plane here.
Theorem 18. If a plane is perpendicular to each of two planes, it is perpendicular to their line of intersection.
Now for the last theorem, which is theorem 18. If a plane, let's say this plane, is perpendicular to two planes, which is this plane and this plane right here, this plane is perpendicular to the line of intersection of these planes, which is this line.